Thanks for coming, everyone. So yeah, Simon Ford. I work at Blecon, where we're building these beacon networks. And I wanted to give you a sense of what's actually changed with Bluetooth, because it's been quietly plodding along in the background while lots of other things have been going on, and you might find quite interesting for lots of the sort of topics people are talking about here. So the agenda I wanted to cover: a brief history of Bluetooth. I'm not going to go too much into the details, but just to set the scene, talk about some of the things around Bluetooth itself and relating factors that mean perhaps the equation has changed for Bluetooth, and then look at it from briefly from two different angles. So what does it mean for more if you're coming from an identity or tracking background, so let's say RFID or cellular tracking, and what about if you're coming from a connectivity background, so like a LoRa or cellular type background. But let's start with Bluetooth itself. So it was around the 2000s that Bluetooth was introduced, which was a cable replacement technology to synchronize your PDA with your computer and things like that, and really took off with actually Bluetooth headsets. That really got it going. What's most interesting to me, I guess, is when some work that people like Nokia and Ericsson were doing on a technology called Wyberry got incorporated into the Bluetooth SIG. So by this time, Bluetooth was actually very established, very popular already, but there was this other technology looking at a much lower power way to make devices connected. That was Wyberry, and that actually got released as part of Bluetooth 4.0 as Bluetooth Low Energy. So they're actually quite different technologies, still 2.4 gigahertz, very cheap to incorporate into the existing silicon that supported Bluetooth Classic. But yeah, Bluetooth Low Energy was fundamentally a new technology that appeared in 2010, and that's what, to be honest, most people should be focused on now, Bluetooth Low Energy. It really had its heyday when it won a socket in the iPhone 4S, so that was the first outing for Bluetooth Low Energy in 2011. And I guess it started on the journey we're interested in today, when Apple introduced iBeacon in 2013. So that really got the ball rolling in Bluetooth, not as a peripheral technology, as a cable replacement technology, but actually as a tracking and identity technology. So I guess most people are familiar with this. In a phone, iBeacon, which basically using Bluetooth Low Energy advertising. You had a device, it advertised using Bluetooth Low Energy, and a phone detected you were nearby this physical location, and it could tell you something. So the way Apple launched it was this can tell you you've walked into a store or something like that to get a voucher. Or the other use case that was really being promoted is you can walk around a museum and it will tell you the exhibit you're in front of. So that really kicked it off, and what drove, I guess, the adoption of the technology into all the mobile platforms. And that was followed by some work that I was working on with Google on your iBeacon. So we implemented the first version of that, and then that became Eddystone. And that was driven basically by Apple and Google as a marketing interaction micro-location platform. But then that technology was also adopted by industry to do effectively asset tracking. So switching the model round, where instead of detecting a person has walked in and that triggering an interaction on their phone, the thing you were trying to understand the location of was actually a physical package or something like that, which had a beacon device on it. So the Bluetooth Low Energy devices were actually moving around rather than being a sort of a micro location technology in a fixed location. And to be honest, this has actually really exploded. So this is, although people think of phones and iBeacon and the consumer sort of world, this is really what's taken off and has actually quietly made Bluetooth one of the most successful IoT technologies already. This is done in huge volume, Bluetooth-based tracking. Yeah, and a natural model where you're getting this data as location into the cloud. So this was sort of what kicked off a lot of things, but I kind of wanted to, this is maybe, say, 10 years ago, but some things have changed that changed the equation for how this technology is applied now. So the first thing is silicon. So this is an Apple AirTag, and that's a pound coin. I should have put a euro. I apologize for that. But the sort of technology that you find in these is this sort of thing. This is a Nordic chip. In fact, the first Eddystone protocol, when that was being developed with Google, I was working on the first version of Nordic's ARM-based Bluetooth chip. So that was the first ever ARM Bluetooth integrated microcontroller. This is the latest one, and you can see for scale these things are really quite tiny, so can be smuggled into all sorts of things. But the sort of power you're getting in something like this is a full ARM-based microcontroller with lots of memory, with lots of security features. So these devices, which are very minuscule and very low cost and low power, are really full-blown computers. So if you If you think back to your Nokia phones of the day, they were running worse versions of the ARM processor than this at much slower speeds and things like that. But then if you go and walk around here and you go and see in-play down there, they get even smaller. So this thing here is an in-play Bluetooth chip from those guys down there, and this is dedicated for actually doing Bluetooth beaconing. Whereas something like that Nordic microcontroller, which maybe costs $1, $2 on a 22 nanometer processor or something like that, very comprehensive silicon. That in-play chip is very dedicated to doing Bluetooth beaconing, hence that can be 30 cents or something like that, and be even lower power because the amount of logic it needs on there is much less. So this is the sort of silicon technology that's now at our disposal today. So it's not just silicon that can produce these packets, they really can be full-on processors that can do all sorts of impressive things on the device itself. From a power point of view, Bluetooth Low Energy by its name is an incredibly low power technology anyway. So part of the move from Bluetooth to Bluetooth Low Energy was changes that allowed it to operate at a much lower power. So by default, Bluetooth Low Energy devices in the sort of world we're talking about would generally run off lithium primary cells. So a battery on the left, let's say that's 250 milliamps hours or something like that. One on the right, that's probably more like 1,000. So with these sorts of batteries, you can run pretty advanced Bluetooth applications for years on these sorts of cells. Already this technology is very applicable for installing in a product that is left, and you potentially never have to change the battery for the lifetime of that product. And that assumes a lifetime of a few years or something like that. But another friend of ours down here is an example of people looking at different types of battery chemistry. So rather than a lithium, like a lithium manganese or something like that, these types of batteries tend to be based on zinc, which is much less dangerous. But what's quite interesting is they're a printed technology, or at least usually screen printed. It could be layered. So they're very thin, they tend to be flexible, but also they're disposable. The capacity of these sorts of things is actually very just dependent on how big you make them. It's kind of, because it's a kind of printing or a laminated type process, it's actually quite easy to change the size these go in. And one of the things we've learned is it's not necessarily people looking for small batteries. Actually, you're often looking to fit a form factor that already exists. So in the case of, let's say, a label, you might actually be looking to fit a 8x6 standard label format. So actually size isn't necessarily your constraint. Yeah, so if you're interested in this sort of technology, you can have a look at Synergy down there. They're based in Cambridge with us. And just I thought I'd show you a video just out of interest of this type of battery technology and why, it potentially is a bit of a game changer. Compared to what you would think about a standard lithium cell, this is not the sort of things you'd be doing to a lithium cell. So yeah, and so here you can see, and this is why they can be made to any size. You can see they can actually, even cutting them in half, they will still continue to operate. So there's obviously trade-offs with this type of battery, but these are really becoming real, or they've become real in the last few years. And what's interesting about them is the type of production process they lend themselves to is one that you can see can become very low cost. So at the moment, lithium cells would be cheaper, just because of the economies of scale they're made at. But these sorts of things, if you actually look at the physics, there's less material and they can be made in even simpler ways. So have the ability to achieve quite interesting economies of scale. And I guess some things are emerging. I believe some people, so Dracula were talking earlier, Epishine is another example. You can even look beyond battery-powered devices to scavenging devices, and these are looking at potentially the ability to avoid replacing cells in the first place. These tend to be a bit further out in the application. Most of the applications we see, they're still looking at primary cells and adjusting the primary cell to meet the lifetime of the application they're being applied to. But obviously these have the opportunity to either extend the life of something or avoid any replacement altogether. And again, this is a printing process. So you can see in the same way as you might end up printing batteries onto a substrate, you can print on these sort of technologies onto a substrate. So some really interesting technologies. These, I would say, are getting very real. The battery technologies are real now. Some other things that have changed is form factor. So when Bluetooth beacons and things like that came out first, they were used for a very particular application. They were stuck in a location and to act as a location anchor. But actually a whole ecosystem has evolved around that, looking at things like putting them in custom enclosures. So this is an example of a beacon attached to a rolling cage. So again, you're not tagging a location, you're tagging an object that is moving around and you're tracking that location. Lots of different form factors that now have sensors in them. So temperature, humidity is the obvious ones, but things like acceleration, VOC, so volatile organic compounds for measuring gases and things like that, and form factors where they're worn. So this has exploded in a whole industry that actually there's OEMs that make all these types of devices. That means they're very readily accessible. But also the technology is established enough that if you want something in a custom form factor or with a custom sensor or to fit a custom application, the likelihood that someone can tweak that, an OEM or an ODM can tweak that to achieve that is very high. So it's one of the competitive advantages of Bluetooth is the fact that so many people now make the silicon and it's made in such high volumes that it's super cheap. But there's also these ecosystem of people making devices that can be leveraged by companies looking to make applications, which is quite interesting. And obviously, when I was first working with Google on iBeacon before Eddystone, I introduced them to a company called Minyu, which I'd found when I was in Shenzhen, who was a very small company at the time. They're now a very big company, and everyone in the Western world would know Minyu if you're in this sort of area. And so you can see in a period of 10 years, the whole ecosystem around this has really, really grown. But I think what's quite exciting for us, so we're obviously providing the networking technology behind this. What's exciting for us is where they're going now. So I would say this has been a very recognized industry for the last 7 to 10 years, and with lots of variations and lots of maturing of that technology. But there's two trends we're seeing at the moment in Bluetooth, which is a move to smart labels, so embedding that Bluetooth technology into label form factors, which is obviously taking advantage of chips like In-Play are making to really get the cost of those chips down and the manufacturability of like a label form factor make that much more simple, and the associated battery technology, which means that coming together, the advancements in the Bluetooth, the advancements in the battery technology, and the advancements in the manufacturing process kind of really make that incredibly viable now. And one that maybe is less interesting to this audience, but is certainly very interesting to us, is that actually this beacon technology, Bluetooth beacon technology, is now being embedded into products themselves. Whereas sensor or a tag or something like that, that is its primary function. What's interesting now is companies are saying, well, I want that function, I want that tracking ability, or I want that reporting data analytics ability, but I want that in my product. The product is actually an inhaler. The product is actually a power tool. The product is nothing to do with the tracking technology or the fact you want a data path, but actually the cost of this has become so low that embedding that technology in as a secondary function of that device becomes really attractive. So yeah, you can imagine in medical devices and even consumer products for analytics and things like that, it's really interesting. So those are two trends we're seeing. So this was one we just announced with Molex yesterday, the day before yesterday. So this is an example of pulling it all together. But you can see, before I put the stupid graphics over the top, you've got some battery cells in there, you've got the sort of circuitry here, this is the Bluetooth chip, and that's packaged in a paper label, and that's activated as you peel it off. So the battery life of something like that is relatively short, let's say 60 days or something like that. But the use case is to put it through a supply chain. So you want something to go into a supply chain and come out at a different point in the supply chain and not necessarily have to return a tracker. So that a lot of this market is dominated by cellular trackers that are very expensive and have to be recovered, or things like USB dongles that are put into food packages that someone at the other end has to take out and take information. So actually this disposable form factor becomes really interesting, that the reverse logistics problem is solved, but the amount of data you can achieve from getting this and the amount of intervention that someone has to do is minimized to get this data is really quite powerful. If you're interested, this is the example of that label that this is very real and shows the technology is really becoming quite mainstream now. So we worked with Molex and In-Play to put together this thing that allows this label to be tracked wherever it is in the world based on hotspots you have in your system, and application is just peeling and stick it on something. If anyone's interested, because this label, we were getting so many questions about labels, we actually put together a smart labels white paper which covers all the technologies that have come together in that. So if you're interested, take a look at that. But it's been really quite inspiring for us, even discovering this. We're a provider of Bluetooth technology, but to go and work with all these companies that are doing, the battery technology, the chip technology, it's really quite interesting how far this industry has moved forward. So yeah, definitely an area that is getting very real very quickly. And then I also wanted to talk about capability, because I think a lot of people we talk to, their capability understanding of Bluetooth is based in either iBeacon or how your headphones connect. So the capability of Bluetooth has really come on a long way as well. So you have the Bluetooth SIG ticking away, adding really excellent features to support the movement of this market. But if you stand back, the things that have really changed how Bluetooth is being applied is things like these beacon networks. So if you've used AirTags, a lot of people think that's a GPS system. It's obviously not. It's a Bluetooth device that is being spotted by Apple phones and laptops that allows someone to track where their AirTag is, or in a similar way I was mentioning about having beacons embedded into a product. That is a pair of headphones. It's not a tracking device. However, the utility of being able to track it is very high. It's still a pair of headphones, but that's now got an embedded beacon in it to allow it to be tracked. So our interest, we obviously have a stand down here. I don't want to spend too much time on this, but our interest is in building the commercial versions of this technology so that people can use it in non-consumer environments. And obviously a lot of that is things like asset tracking, medical devices and things like that. So yeah, we work on enabling all these sort of existing devices that are already out in the field, like point of sale terminals and Android barcode scanners. We can enable all them as hotspots in a Bluetooth network, and that allows companies to get tracker information and data into their back-end systems. So that's what we're doing, and it's actually put us in quite a privileged position to see what's going on in this market, which has been very insightful for us. But when you start thinking of these Bluetooth beacons more as networks, you start to see what the capabilities are that pop out. So now a device, let's say this cage tracker, as it moves through a supply chain, rather than, let's say, just round a warehouse, if people have thought about it in terms of RTLS, like real-time locationing systems, which have tended to be quite constrained, you can now see how things can be tracked through a supply chain, so through a disparate system, using these same sort of beacon network concepts. So a lot of these forklift trucks have a zebra device that is where the person knows to go and pick things like that. That can act as a hotspot. When it's being the GPS on someone's van, that can be a hotspot, and a point of sale terminal when it reaches the frontline store. Let's say it's a retail store or a food outlet. That can also be a hotspot. And you can really piece together some quite impressive information from these sorts of systems, partly because of the ubiquity of Bluetooth. But you're sort of leveraging the cheat code of Bluetooth, which is that it's in all these devices already, which is a privilege that a lot of other technologies don't really have. RFID and LoRa are not embedded in every phone. They're not embedded in every laptop. Bluetooth is. So that's, is that a technical advantage? Not really, but it's totally an advantage in terms of the pragmatism of how you solve a problem. So this is why I think Bluetooth is actually quite interesting if you look beyond just the technology, which is already a very impressive technology. And the other thing that's happening is Bluetooth in the form of beacons has been used a lot for location, right? Spotting a beacon, spotting advertising. But there's a real strong demand for more than just location. There's demand for data. And what that's evolved is beacons that actually can open up a connection to a cloud backend and communicate two ways and have security on that channel. And you can attest it really is that device. And the device knows the real time. So if it records an event and another device records an event and they come together in the cloud later, even if they arrived at different times, that data, you can synchronize all of that information. And really this highlights how, when you look at really quite large scaled systems, most people are not looking for interventions on an individual product or device. They're looking to get a whole view of a supply chain or a system. And actually the intervention is at a system level. So actually having all the data is more interesting than having the data quickly, which is a really interesting trade-off that's not so obvious and perhaps not where things have evolved for. Okay, so this is quite an interesting change that Bluetooth has enabled. And you can see, if I took that same example, a device on a cage might spot another Bluetooth device. Even though it's out of any coverage range, it now knows, or at least it can record where it's been. It can record that it's seen other devices that are similar to it, or maybe when it last saw them. Let's say one left a lorry. There's no coverage at that point where that rolling stop, the cage left the truck, but another peer that is going to get back to the warehouse can say where it last saw it. You can log events like impact, and we've got a nice demo on our stand at the moment where we're actually using an AI model on a device to measure impact and characterize it, using an accelerometer to characterize the type of event that is experienced. And then at some point in the future, it can synchronize through one of these hotspots, and all of this data can be synchronized to the back end. And that's really transformative in how you think about architecting these systems, because suddenly it's not about having coverage everywhere you need to have visibility. In fact, it's quite the opposite. There can be places where that synchronization happens, but your system itself can be very disparate. Yeah, so super interesting as these beacons are getting smarter. I guess there's some other things if you think back to where Bluetooth was starting to use in these use cases. Security and things like that weren't really that important because it was just to trigger something when you walked into a Starbucks or something like that. But actually, as the requirements have changed, so have the requirements on security. So actually, it's now possible to support cryptographic identities on devices, so you really know which ones they are, and you can attest it really is that device when you see it again, and that means it can't be spoofed. So actually, the reality of a lot of Bluetooth tracking systems at the moment, if you looked under the hood, they're just transmitting identities in plain text. It is an attack vector. So these are the sort of things that are now perfectly solvable. The same with privacy. Actually, not only people who need to know can know what an object is, or even changing identities. And we've even taken this further, where these Bluetooth devices can now represent GS1 EPC identities, which is really interesting. So this is not something that's really been done before, but actually the world of tracking is very much based in things like GS1 for barcodes, for RFID, but a lot of Bluetooth has been based on things like MAC address or whatever. Actually, if you bring Bluetooth into that world, potentially it can sit alongside an RFID system, a barcode system, and we've seen some really interesting hybrid use cases where actually the combination of RFID and Bluetooth, not in the same device, but in the same problem set is really interesting. And obviously GS1 EPC, like EPCIS, things like that support the concepts of composability of identities and into other entities, and so a set of RFID identified devices can be brought together. Maybe that's now identified by a Bluetooth and tracking identity, so you're tracking this through a system. Anyway, so super interesting where this is going, and this is all enabled by how this Bluetooth technology has evolved. So I thought I'd end by just trying to put this in context from the two views of the different types of customers we end up talking to. So one is coming from the identification and tracking direction, and the main sort of positioning that certainly we see most is, well, I'm looking at RFID, I'm looking at Bluetooth, and I'm looking at cellular. So to be honest, I think most of the interest is coming from this side at the moment, where they know tracking is valuable to them, but they want to take it further down or do it more broadly. So you have cellular trackers that are high cost and high power. That obviously impacts how you can operate them, the logistics, the reverse logistics, things like that. Moving to Bluetooth, especially with things like labels, things like that, really changes the equation for people. There is, I think, less so do we see people moving from RFID to Bluetooth, but actually a lot of applications that RFID isn't solving, Bluetooth can solve. So I wouldn't say, this is definitely a transition. I wouldn't say this is a transition. I would say this is a different application that RFID hasn't been able to solve historically. So that's what we see from more the identification angle. And then from the connectivity angle, this is normally what we're seeing. The sort of technologies people are using when perhaps they either want to carry data, or it's primarily a data carrying application. They're looking at mobile, they're looking at LoRa, and they're looking at Wi-Fi. To be honest, Bluetooth has never been considered because of it's effectively a LAN model that, and it's a cable replacement model. So it's never really been applicable. But with the sort of advent of the smart beacons who can really make two-way communication without having to pair and being able to use whatever hotspot happens to be nearby, suddenly Bluetooth looks much more like a LoRa technology. And that's really exciting for a lot of people. So suddenly you're opening up applications that you thought LTE or LoRa were the only real ones that you were going to be able to use, to being able to use this Bluetooth technology and leverage the cost advantages, the ubiquity advantages, and even the fact that things like the frequency are global. It sounds silly, but if you're building a LoRa system, it is regional. Bluetooth is a global standard. The phones that it's talking to have already solved the cellular problem in their local geography. So again, it's another interesting cheat code. Yeah, so just to wrap up, what we've seen that's very interesting here is Bluetooth beacons, as they've got smarter, they're actually opening up all sorts of interesting operations. I'm not going to go into that, but they really start to look like a proper IoT technology, which is really quite exciting. And actually, we're going to run a speed lab 1 o'clock, just down here, where Garrett will show off these labels in action, including the tracking. And we even actually have something where, while some of our trackers were en route, the team back in the office were OTAing them to add AI algorithms as they were in transit, because you could do that as we were driving here from the UK. So that was pretty exciting to see that really all come together. So if you have a second, if you want to go down there at 1 o'clock, you'll get to see these labels and some of this tracker technology in action, which is quite exciting to see. This is a white paper we wrote on trying to pull all this information together, which you might find interesting. Yeah, beacons are a really exciting technology as counter to, say, Bluetooth peripherals, Bluetooth beacons. And they've really come a long way, and we continually find that people haven't quite understood quite how far they've come because they haven't made much noise. They're not necessarily the most fashionable thing in the market at the time, but it's a really impressive technology, so we'd encourage you to check it out. So thank you very much. Thank you.